Good morning, everyone. What I'm going to go over now is bypassing ASLR and DEP NX. So the first thing I'm going to do is I'm going to cat proc sys kernel randomize VA space. And as you can see, it's 2, so that's good. That means ASLR is turned on. So I'm gonna go over to my desktop. Whoops. My desktop, and now let's open up GDB PETA and open our vulnerable function. So I've disassembled a main function. And looking down through, here's another function here. So I'm going to disassemble the vuln function. And as you can see right here, here's our stir copy, which doesn't do bounds checking. So right before this call, I'm going to put a breakpoint here. And then I'll just next instruction into it. So right now, I don't know the size of my buffer. So let's open another terminal here. And I'm going to open Python Freya. And this is just a little bash script. Python. Here we go. Little bash script I have written here. And I'm going to run the fuzzer. I'm going to get 1,000 character block for my fuzzer, and I'll just open up the output here. And here's what I'm going to fuzz the application with. So now we'll open in mousepad here, and as you can see, there's a lot of crap here. So I'll just fill this here with my fuzz. So now this should just output the buffer. So that's all good. So I'll save that. So that's my exploit. I'm going to turn that into a payload. So now, first things first, we're going to set disable off. And now let's run this program with our fuzzer. Next instruction, and then I'm going to display 132 words of hex from the ESP. And as you can see, it's all filled up here. What I'm going to do now is continue, and then we're going to see where the program crashes and what's in the EIP register. And as you can see, we're SIG-SEV, so we're crashed. And right now in the EIP, I have AV 4V. So now I'll just come back here to Freya, and I'm going to run the offset. And you can use pattern create and stuff with MSF Venom if you want, but I just have my own thing set up here. So 268. So that tells me my buffer size is 268 bytes. So now I can start crafting my exploit. So now I can get rid of this fuzz here. So now I can do times 268. So this will give me 268 A's. Now what I want to do is make room for my system functions. We're bypassing DEP as well, so we can't have anything executable on the stack. So we're going to dive into the libc and grab the addresses, and that's how we're going to get past NX DEP, and then we'll use a while true to brute force the ASLR. So that's the plan. So that looks good. So I'll save here, and let's turn that into a payload. for our, and everything looks fine. Okay, so let's go back to our binary here, our vulnerable binary, and we'll cat payload, hit next instruction, and display. So as you can see, our A's have all filled up the buffer right up to here, and here's our EBP. So what I can do is print EBP, whoops, print. So here we go, 61A8, so 0, 1, 2, 3, 4, 5, 6, 7, 8. And as you can see, it's covered up with all our A's. Our 42, which is our B placeholder we had in our exploit right here, that's covering the return address. So this is where our system function is going to go to bypass DEP. Next, we have our C's right here, and everything's lined up good. This is where our exit function is going to be. And then our D's over here, this is where the bin sh is going to be. So why don't we find that stuff right now? So we got system right here. So I'll copy this. And let's put this in right here. I'm going to get rid of these two here. Okay, that's our system. Let's find our exit function, which is right here. Perfect. And now we have to use find bin sh. And there's our function for that one there. Okay, so let's do this right. Whoops. Edit, undo. Let me just comment this one out, and let's put in our next address. Like so. Okay, so now we need to start putting these in. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, so let's start off with our system. So we need to put this in a little Indian convention. I'm not using struct library today just because I want to go over the basic function of this. And B7. Next, we're going to put in our exit function, which is 50, 6D, CE, B7, and finally, we're going to put in AA, 60, AA0F, sorry. E6, B7. Okay, so now I'm going to hit File, Save. I will run my Freya again and turn that into an exploit. Everything looks good, nothing crashed. So now let's run cat payload. Okay, so next instruction. Okay, as you can see, all our 4s are covered up. B7, CF7910. That looks good. Now ASLR is turned on, so like this time around, it probably won't run when I do continue. But what we will do is brute force this with a while true loop. So that looks good. Okay, so SIG-7. So we have the right exploit. So now we're not going to be able to do this in PETA because we can't do a while true inside of PETA here. So let's go back out to our desktop. Whoops. And that one's locking up on me. Okay, so what I'm going to do, I'll do a while true, do our vuln program, then we cat payload, Done. Now the entropy is so low on a 32-bit system that we can actually just brute force this. There's only like 8 bits difference between ASLR on a 32-bit system. So that's how we're going to get around this. So while true, boom, we have shell. So that's bypassing data execution prevention and address standardization, layout randomization as well. I hope you enjoyed, and I shall get back to you with some more fun exploitation stuff really soon. Okay, have a good day.